All right, so now we're going to look at some additional TTL IC chips. TTL is transistor logic, and that's what this whole 7400 series chips are. So I have my hex inverter. I have a 7408, which is a quad AND gate, and I have a 7432, which is a quad OR gate. And the pinouts of those I have down here. You can see that I have inputs 1 and 2 to an AND gate. The output's 3, 4, 5, output 6. And up here I have a mirror image of that. You notice my OR gate is wired exactly the same way, it just happens to have OR gates internally rather than AND gates. And in fact, if you look down, 7400 chip is got 4 AND gates. 7402 is NOR gates, which is very similar except it runs the gates the opposite direction. So 2 and 3 are the input, the output 1. And even up here, 7486 is exclusive OR. 7266 XNOR gates. 74133 has like a 13 input NAND gate. So I can look up any of these inputs, but the ones we're going to use now are just these two. I have them here. You can look up those pinouts for yourself. So what I'm going to do now is just take my circuit. I've already gone and put all my chips down. I put power. I put ground. I'm going to turn voltage on. The light's there. I'm going to double check my voltage to everything before I move on. So I'm going to make sure I'm at 5 volts. And I should do that before I turn it on, but I had 5 volts already set. I'm going to go and check the pin 7 of each one to make sure it's grounded properly. So it should show me about 0. You see they're all way down in the millivolts. Now I'm going to go up here for the VCC, which should be 5 volts on pin 14, and it is in each case. So my chips are properly powered. I'll also check all of them by finger just to make sure they're warm. Are not warm. Okay, now we're going to try our AND gates out of our 7408. So I'm going to take I'll just use A and B this time. I could use any of these switches too, but I'll use A and B. I'll just go into the closest input, which would be input number 13. Next closest is going to be 12. I have to use them both on the same AND gate, so I don't want to mix and match these and put them in 2 different AND gates. So they both go into the AND gate. Now I'm going to take the output of that AND gate and just take it up to an LED. I can pick any one I want. As long as I'm just testing here, I just pick an LED. So we know that for an AND gate, 0 and 0 should produce a 0 out. 0 and 1 should produce a 0 out. 1 and 0 should produce a 0 out. 1 and 1 will produce a 1. So my AND gate's working properly. I want to go through the logic and follow it. Again, 0, 0, 0, 1, 1, 0, and 1, 1. AND gate's working fine. I could go through and test the others if I wanted. Now I'm going to go over and I'm just going to try the OR gate. OR gate is hooked up exactly the same way. So the output is going to be here. Don't worry about the light coming on since nothing's going into it yet. Okay, so inputs are 12 and 13. Output is 11. Okay. 0 or 0 is 0. 0 or 1 is 1. 1 or 0 is 1. 1 or 1 is 1. So my OR gate's working properly. Produces exactly what I expect. Again, I can go through and work through these other OR gates and check them. But I've got now an inverter, AND gate, and OR gate. In fact, I have 6 inverters, 4 AND gates, 4 OR gates that I can use to build a more involved circuit. So what I'm going to do now is I'm going to introduce a circuit. I'll lay it out right here. I'm going to run 2 inputs into an AND gate. I'm going to take the output of that AND gate and I'm going to go into an OR gate. the other side of that OR gate is going to come from another switch that's going to go through a hex inverter. And then I'm going to take that output of that OR gate through another hex inverter and up to a light. So if I want to do this, I'm going to start by taking A and B, and I'll just leave these A and B. I don't have a C. I could make this A, B, and C, but I'll just make this A and B, then I'll make like 7C. And I'm going to take A and B and run into an AND gate. So I'm going to move A and B back over to this AND gate I was at before. And the output of my AND gate is going to go into an OR gate. So I can pick any OR gate. I'll just pick the one I was using before, and I'll just cut a little wire and run over to that. So the output of my AND goes to the input of my OR. I didn't pre-cut these wires, so let me do this real quickly. Now, as you work further, you want to make these wires a little tighter and neater. But early on, we're just learning this, so I'm doing this a bit like I'd expect to see yours, but you can certainly make it neater. So I'm going to go out of the AND into the OR. Okay, the other side of the OR comes from a hex inverter, and that hex inverter is fed from C. So I'm going to go way up here, and I need a longer wire, so I'll get a longer wire. So I'm going to call switch number 7 is going to be my C. I have to run it to a hex inverter, so I'm just going to run it down here to this hex inverter. Made that wire very long. Now I'm going to take out of that hex inverter and run to the other side of the OR gate. We'll go back and review what we've done here in a second. So the other side of this hex inverter, a little more insulation. So let's pull that off. So I can kind of tuck these down out of the way so it's not so sloppy. That goes into the other side of the OR gate. So let's review what we've done. A and B go down these two wires, and they go into an AND gate. The output of the AND gate goes into the input of an OR gate. C, which is up here, goes into a hex inverter, out of that hex inverter into the other side of the OR gate. Worth noting, I can pick any of the hex inverters down here I'd like for this hex inverter. I could pick any of the AND gates I would like on this chip. I could pick any of the OR gates. I just picked the ones that seem like they're the most easy to get to. There's no reason other than that for what I picked. Finally, I'm going to go out of that AND gate and into a hex inverter. So what I'm going to do is just take a wire I already have cut that's a bit long, go out of the output of the AND gate. I'm going to go back into another hex inverter, so I'm just going to pick the one out in the end. And finally, I'm going to run the output of that hex inverter up to an LED. At this point, okay, so I have a light that comes on. So it's doing something. I'm not entirely sure what, but it is doing something. Well, how do I figure out if it's working correctly? Well, the next step is I really need to go through this and put together a truth table and come up with what my possible outputs would be of this and compare them to what I get from my circuit. So what we're going to do is I'm going to sit here and I'm going to create this truth table. So let's do that. Now, before I do the truth table, one of the other things I'd like to do is just go through how I decide where my connections were on this. So I'm going to do that in another video, though, just so that we separate these a bit.